Okay. So thank you for the introduction. So my name is Bojan Vrhovnik. I'm a cloud solution architect working for Microsoft Slovenia. So today the idea is to basically go through the options that you have on building your own kubectl. Now kubectl is basically, kubectl is basically a Kubernetes command line interface tool that is officially basically provided by the Kubernetes team. So the idea here is to go basically how you can write your own kubectl. So I'll try to do as much as demos as possible so that you can see how you can work with API server through C#. But first, the idea is that you have. So I'll be using, in this case, I'll be using K for kubectl so that you can see how I'll be perform specific actions. But kubectl is just one of the tools that you can leverage on the market. You will see that you have a lot of other tools that are quite good, basically. So you have, for example, Rancher, you have Portainer, you have Lens. And each of them are basically leveraging the same endpoints and the same stuff that we'll be talking about today. So what I'm talking about is, for example, Lens is one of the tools that kind of gives you an ability to basically perform some specific actions towards Kubernetes as such, which means you have a graphical user interface which you can interact with, which means that you can then go and check, for example, deployments. You can check, for example, pods in this case. You see that I have a pod, you get back the information, and all of these tools that you see here can be basically easily reproduced on your own. Now, why should you basically do this kind of stuff? It's very simple. Now, at least with the customers that I was working with, there was a lot of confusion, when to write their own tool in order to basically communicate with the Kubernetes cluster itself. Now, to do this from scratch, it's not easy, even though the client libraries that you have, even though the REST API is quite straightforward. But the problem is with a lot of other stuff, with versioning, with basically with bugs, with a lot of stuff that you need to take into consideration. Now, Portainer, for example, uses the same approach, but it uses basically a web interface. So here I have a Portainer living on a Kubernetes cluster, which you can run really easily because it has a really nice Helm chart that you can then take advantage of. And you can do basically the same stuff. Now, each of these libraries or each of these applications that you see here have three things in common, right? So first, they have their own ways of basically interacting with specific workflows, right? So for example, Portainer has a really nice way of basically going through Helm charts. So it has a web interface which you can then interact with, go through to see what kind of Helm charts you have, and then you can execute those Helm charts towards the Kubernetes cluster behind the scenes. What is really nice as well is basically when you go inside to get additional information that you can see. You can basically add registries. You can do a lot of stuff, right? And then it has also business option as well. So the idea is not that I will show you, different tools and how you can use them, but rather to basically build the stuff on your own. So all of the demos will be available on GitHub. So here on GitHub, if you go under my username Vrhovnik, you will see all of the demos that I'll be showcasing today. And you can basically go and fetch that out. The things that I will try to point out is below you have a links section, and in the links section you have a few interesting stuff that you should check out. Because it will guide you through the whole way of how to basically build the tool itself. And also you'll find some useful helpers, especially this one, which I use frequently, which is called AKS Deployment Helper. So if you'll be deploying Azure Kubernetes clusters, for example, from Microsoft, here you have a really nice web application which goes through best practices that we have in order to deploy Azure Kubernetes cluster. So it creates on the end, based on what you select, it creates a script which you can then leverage and deploy the application either in test or either in production. Okay, with that, let's go to the first for the first section. How to do that. What we saw, with different tools, with GUI, with web applications on their own. Now, in order to do that, you need to understand a few things. This is just a reminder for all of you who already know, how Kubernetes works. You have a user, either that user is a service account, either that uses kubectl, or either that user is a actual user, which then communicates with the API server. With the control plane, he tells what he wants to do, what kind of state he wants to perform. And when that state is basically saved in a database, then the control plane makes sure that that state is then replicated through the application to the nodes that are available on that part, right? Now, the magic word here, when you're working with building your own tool, is basically the API server, because the Kubernetes team exposed a lot of RESTful endpoints that you can then take advantage of, which means if you know how to perform 3 little things, you can basically do whatever you want, right? So the first thing that you need to understand is, of course, the easiest part, how to authenticate yourself, to present who you are. You can do that on multiple ways. Either you basically create a special file which is called a kubeconfig file, which contains 3 important information. That information is basically cluster API URL, which is the easiest one. The second one is basically the user that is connecting, and the third one is which authorization methods he uses. Now, the authorization methods or authentication methods, you can basically either use client certificates, either you can use a Bootstrap token, single token, you can use basically JSON Web Token, you can use OpenID, you can use basically webhooks, which is really nice, if you have, for example, Azure Active Directory or some other OAuth provider, which does the authentication for you. In that case, you can basically use, webhook authentication, and that will be done for you. The next thing that you need to have is you need to know what you can perform on that specific cluster, right? In that case, which means, you need to have airbag defined, and in order to create, tokens or create certificates, you need to be cluster admin, which is, logical. And the third thing that you need to be aware of is basically something that we call admission control, which is a group of software module which is installed by the, if admin installs the Kubernetes cluster, it defines which admission controls will be available. Usually, the admission controls are something that is happening after the request is authenticated, and it can basically then modify modify or reject that specific request, and it can read the object that is going before it's going to be saved in that specific state. Okay, so let's go and check how that looks like in action. So in order to basically create, for the demo purposes, I created a few things. So I already have a service account, which is this demo user. That demo user is cluster admin in this case, because we will be playing around with different ways how you can then interact with the cluster itself. And as you can see here, I already have a secret. I have a service account token, which is on the end, when you get the secret back, it's basically a bearer token that we'll be using in our request going forward. So if I open, for example, Postman, the first thing that I will do is, and I will show you where we are communicating to. So I have a cluster, and this cluster is basically located in this area. So which means I'm using Azure in this case in order to connect to that specific cluster. And if I go and check, if the cluster is alive, I can do that, issuing a request which has an authorization attribute as a header, which contains basically two things, right? So it contains a bearer token and it contains some additional information that is on the end, the one that I'm requesting to, right? So what I get back is information about my cluster itself. So here you can see what is available. You see that I have that ping to that specific cluster is okay, which means that we are on the internet, which is even better. So what we can do with that one, if we go to the API server itself, which is this one, and issue a request to that specific endpoint, and of course, when we are authorized with a specific way, in my case, Bootstrap token, what we get back is a list of endpoints that we have available, and here you can see that we have quite a bunch of them, right? Now, all of these API follows specific conventions. Depends on the API, depends on the version that Kubernetes cluster is on. And here what you can see, if I go, for example, inside of APIs apps, right? So here you see that I have API apps version 1, right? So if I go, for example, in that one and say that I would like to go to APIs, if I know how to type, APIs, apps version 1, and execute specific, that one. What I will get back is then an API resource list with a specific version. And if you go, for example, down a bit and search for example, for a deployment, you will see that I get an option to basically then, work with specific deployments, right? And what I get back is information about what I can do with that specific API, what kind of actions can I perform, and so on, right? So let's go and then do, for example, a simple list namespaces. So here I'll be basically connecting to the cluster. Instead of using APIs, which is an API group, I'll be using, API v1 namespaces. And when I execute this one, I get back information, which is, get all of the namespaces that are located on that part. Now, what API returns back to you is three things. So the first one is the kind part, which is either it's a collection, either it's a simple object, which means, status, collection, pod list, or it basically gets back to you an object, which on the end is, for example, I don't know, pod or deployment or status or something like that, right? Now, if you want to know how to interact with these specific APIs, you have a really nice documentation, which goes through, how the API convention works. It's on GitHub, and what this does is explains, what you get when you issue a specific request to an endpoint, but in essence, what you get back is always you get back the metadata, the kind, and the version that is located for you. Just keep in mind when you're creating, for example, a new namespace for clusters, you cannot use cube minus prefix, and you cannot use the DNS, which is key8s.io for your demos. Okay, now, if I go here, I can then, perform also details, which means, issuing requests, getting back the results, and everything is basically really, really easy to do, right? Because it's just REST. Now, if we go to C#, right, then what we can do is we can go, for example, in a library, and we can, get back we can take the master URL, we can take the bearer token, we can take the HTTP client, which is the common way how to interact with the network resources. And what we can do is perform the same operation that we did with Postman, right? So what we can do here is go and say, look, we would like to have the master URL, we will have the bearer token that we will get from the environment variable here, and then what we will do, we will send a request to that specific data. Now, what we will get back here is the whole JSON file, because all of the requests, when you issue a request inside of the API master, you get back a JSON. What we can then do is then, take that JSON and convert that JSON into C# classes, right? Which means you can use either, a plugin or, whatever, for that purposes. And if we go, for example, inside of these pods, and these pods is then, the class representation of the JSON object that you get back from the API server when you issue a specific request to that endpoint, right? So, what we will do now is execute that specific request. That request will go and, it will read the bearer token. It will issue a request. I will issue a request to the default namespace. And when I go, for example, over, you will see that I get back the JSON representation of that specific part, which is, a bunch of JSON values. And if I go and then convert that values into inside of objects, and do F5, what I will get back is then, results. Oops. I will get back the results, which are then, pod test, which uses a specific container, right? Because that is the information that I get back from the cluster itself, right? So here you see how that code is implemented. It's very simple, because I just traverse through all of the JSON files that you have behind the scenes, right? Really easy. Now the trick here is, this is just a simple example, right? The trick here is, what if I want to have some advanced functionalities, right? What if I want to, for example, do some port forwarding? What if I want to do some exec, right? So how to do that from C#? Or maybe I want to have a scenario, right, where I have, for example, a web store application, which I want to then provide, for example, trial version, right? And I want to modify the values at real time. I want to do that automatically. So how to do that, right? Because, frankly said, if you do this in a sense that you will basically copy paste all of the JSON files and then convert them to C# files, that's basically, right? It's not the way how you should do. That's why we have an official library from management, from Kubernetes team, which is called a Kubernetes client. So in order to use it in C#, what you need to do is basically three things, right? So you need to just add a .NET Add package, Kubernetes client. What I would really like to point out here is, it's cross-platform, which means that you can leverage, Linux deployments, you can leverage Windows deployments, you can even run it on Mac. So the Kubernetes client, what it has an auto-rest implementation of all of the functionalities. And it uses a way of reading all of the files that you need behind the scenes. And I will show you how this looks like, right? So what we can do when we add the Kubernetes client package, and if we go here, what we get is basically Kubernetes configuration class. And then we have iKubernetes client as an interface, which you can then replace based on what we need, right? So what I'm doing here is I'm reading the config file that I have in kubeconfig. And then I have my own classes, which are, for example, namespace operations. Now, if I go inside of these namespace operations, what I get here, and you can see here, is I get basically a way of instead of me doing all of the traversing of the objects inside of JSON files, putting all attributes, this is basically done for me. So based on the API convention, I can then use APIs and then get back the information itself. Now, here what you will see is I have list namespaces, but the most interesting part here is the delete namespace, right? So with the delete namespace, we know that when you delete a namespace in Kubernetes cluster, it's not deleted, immediately, right? Okay, of course you can force it, right? But it has specific states. First it's terminating, then, it's deleting all of the resources inside of that object, right? So how can we basically then, get information about what is happening behind the scenes, and how can we do that, with the use of clusters? So what here I'm doing is issuing a delete statement, and then I'm using a recursion, which is here, calling until I get an exception when I read the namespace, right? Because the namespace, when it's not available anymore, it will throw an exception, and then I will, catch the exception and then do a specific part, right? Okay, so this is what is happening here, and then I have the workloads operations where, I basically work with the workloads. Now, the most interesting part here is, we can read the pod, right, which is really easy. You call core v1, we get namespace pod, specify the values. Now, the trick here comes when you have, for example, advanced functionality. So imagine that you have a functionality where you want to implement a watch, right? So you have, for example, you create an item, and then somebody deletes the item, and you want to basically have control on, when that action happens. Of course, you can have webhooks, right? But in some cases, that's not possible, right? So that's why, how can you do that, for example, in this case? So we have a implementation of a socket, which connects directly to the praise, and what you can do is then, create your own, for example, watch, your own delegate with event, and then react on that based on that event, right? Or maybe you want to, for example, exec into a specific pod, right? So, to explain what I'm talking about is, you go here, you say, I would like to get all of the pods, and then you get back the pods, and then you say, oh, I would like to exit into pod minus test, pod minus test, and I would like to execute, for example, ls command, right? So you're executing into that specific pod that is running on the Kubernetes cluster, and then you get back the stream, and you want to connect to that specific stream, right? So that can be done as well, right? So let us check, the demo so that you can see how this works. So the first thing that will happen is list all of the namespaces, right? So let me go into the debug part. So you will see now that I'm reading, all of the namespaces. So here, what I get is also, I'm reading also the labels of that specific parts. And then, it's asked me what kind of namespace would I like to create. Let's say that I would like to create IC-web, and now IC-web was created. So if I go, for example, here and say, get me namespaces, you will see that, IC-web was created, 7 seconds ago. I can delete the namespace, and now be careful what this will do. If I do yes, you will see that it's terminating, and then, checking if that specific namespace is still available, doing the recursion, and after a while, it will basically execute and it will delete the namespace itself. So the next thing what I want to do is basically, go and execute workloads operations. So here you will see that I will output some pods, and then I will create a pod with a specific random name. I will output that pod, and then I will execute a watch on that specific namespace. So let me execute that one. So now what this will happen, I will select, for example, in this case, default. Let's say that we would like to use nginx. And now you see here, I'm listening basically to what is happening with that specific pod. And now I can go in this one and say, I would like to get all of the pods again. And you will see that CSI was done. So I can do then say, I would like to delete that specific pod, and be careful what will happen here, right? In a specific namespace, I do that, and now see, all of the events that is happening. I'm basically getting back information inside of my application that is running behind the scenes, right? Even better, right? And now I can go I skipped one part, which is reading a YAML file. But let me just do a demo, and then I will explain what it does. When I do true, what this happens is throws an exception, which is not okay. But okay, maybe I will show you what the point is, and so that you will understand. So, besides remoting into that specific pod and executing some items, what you can also do is read YAML files programmatically in real time. And I have here one YAML file, which is basically a very simple YAML file, which contains a service and a deployment. And what I can do is read that specific YAML file. So what I can do is load that specific YAML file. And then what I can do is modify that specific YAML file based on the needs that I have, right? For example, if I'm getting from the YAML file that it contains a service, create a namespace service. If it's a pod, create a pod. If it's a deployment, because the deployment has an environment variable which is called production const string, I can then go and basically change that production const string, which is called a little bit different. That's why it didn't work. And then I can basically execute the whole operation, right? Let me exec into the pod so that you can see how that works. Let me repeat this procedure. It will run. So, and Jinx. So I will say false here. And what you will see is, in this case, it will read that I have a deployment and I had a service, right? Now I will execute exec, the stuff that you saw, that I was doing here when I did an ls. So I'm doing the same stuff here, but I'm doing this with a code, right? So what I'm doing is getting basically a pod. And now what I'm doing is opening a socket connection with a special class which is called a stream demuxer, which is just an implementation of a socket connection, and then doing the whole implementation. So here what I'm doing is just doing an ls inside of that specific part. So what you will see is doing an ls. If I go a little bit up, you will see the result of that ls inside of that file, which is basically this stuff that is outputted here. The point that you see on the end is just node metrics. So because what I can do as well with C# library is then connect inside of node and get back the metrics of the node itself, right? So I can get all of the metrics that are inside of that specific cluster. Okay, so as you can see, the library is very simple to use. It has a lot of advanced functionalities, but when does this comes into play is when you have a mix and match with a specific library. So let me show you that one. So I have a simple web application here. So what this web application does, and let me run this web application so that you can see what this will do, is imagine the scenario that I explained before, the web store part, right? So I will go and now log in with Azure Active Directory. And here you will see that I have a scenario simulation, right? So I will click go and imagine the scenario that I explained before, right? So imagine that I have now the web store and I want to create a trial with all of the changes that is happening behind the scenes. So I'm using the same library, and what I will do here is say IC-web, for example, or ICW, and I will say create a scenario. So what this will do behind the scenes, it will deploy a YAML file. It will change the values of those specific YAML file. It will create a service IP on the load balancer. It will get the IP back. And what I can do then, when that will be done, here you can see that I have an IP which I can then visit. And this IP will show some web application. And then I can take advantage of, for example, Azure registry, and of course, Azure public IP address behind the scenes. And I can apply, for example, a custom domain on top of it, right? So what I can do, so this application that you see here is basically a simple web application. And what I can do with DNS name is say, for example, I would like to have IC-web-test, for example. So I will assign a frequently qualified domain name, which will be, when it will be created, it will then automatically redirect to that specific URL. So, now I have a production software. Okay, I didn't deploy the SSL certificate, but I have a domain that is created behind the scenes, which does the stuff that I mentioned, right? Now to wrap up, just to show you the code itself. The code is using the same libraries. So I have a CRUD service here, which uses the Kubernetes client libraries, and it performs basically the action that you saw before, where we were playing with the API itself. So the API is really powerful, and you can basically take advantage of the API to get basically functionality that is required for your specific user scenario case. So hopefully this was useful, and that you will check out the API itself. Check out the libraries that you see here. For example, the API, the code to basically assign a domain name is also located here, so that you can see how you can then randomly apply also domain names. And if you go to this specific URL on the end, this one, you will get back all of the links to the source code, to the APIs, and basically to everything that you need in order to start building your own Kubernetes tool. Hope this was useful. If you have any questions, I'll be here, and enjoy the conference.